Value sheet D, question 3. A reliable estimate for the proportion of a population of fish with a certain degree disease is 60%. A test for the presence of the disease in a fish is possible. The test gives one of three conclusions: diseased, inconclusive, non-diseased. For a diseased fish, the probabilities of these three conclusions are diseased 0.75, inconclusive 0.15, non-diseased 0.1. For a non-diseased fish, the probabilities of these three conclusions are diseased 0.05, inconclusive 0.15, non-diseased 0.8. We're now going to put this information into a tree diagram. A fish could either be diseased or non-diseased. When the fish is tested, if it's caught and tested, the test could say it was diseased, it could be inconclusive, or it could say the test was not diseased. If a fish didn't have the disease, the test again could say it actually did have the disease. It could be inconclusive, or it could say the fish was not diseased. So the probabilities would be 0.6 for diseased fish and 0.4 for not diseased fish. If it's diseased, the probability the test would say it was diseased, 0.75. The test would be inconclusive, 0.15, and it would say that the fish was not diseased, 0.1. If the fish was not diseased, it would say it did have the disease, 0.05. It would be inconclusive, 0.15, and it would say it was not diseased, 0.8. So then working out the probabilities of 0.6 times 0.75, the fact that a fish would be diseased and the test would show it was diseased, 0.6 multiplied by 0.75, which equals 0.45. A diseased fish and the test being inconclusive would be 0.6 multiplied by 0.15, which is 0.09. A diseased fish and the test saying it was not diseased is 0.6 multiplied by 0.1, which is 0.06. A non-diseased fish and the test showing that it was diseased is 0.4 multiplied by 0.05, which is 0.02. A non-diseased fish and the test being inconclusive, 0.4 multiplied by 0.15, which is 0.06. A non-diseased fish and the test showing that it was non-diseased is 0.4 multiplied by 0.8, which is 0.32. So for part A, a fish is selected at random using a tree diagram or otherwise calculate the probability that the fish has the disease and the test concludes that it is disease. So probability that it has the disease and the test concludes it does have the disease, so that would be 0.45. A, part 2. The test concludes that the fish has the disease. So that would be that one or this one. So for part 2, 0.45, add 0.02, which equals 0.47. For part 3, the test gives a correct conclusion. So it could be that it was diseased and it said it was diseased, so that's 0.45. Or, so we add the probability, it could be not diseased and the tests show that it's not diseased. So add 0.32, equals 0.77. Part B. 3 fish, all with the disease, so we're only interested in these 3 here, are tested. Find the probability the test concludes that 2 fish are diseased and 1 fish is not diseased. The probability of showing it is diseased when we're only looking at fish that are diseased is 0.75. And we want 2 fish are diseased, so we want 1 fish that is diseased, another fish that is diseased, and then the third one being non-diseased, which would be 0.1. Now we could have them in any order, so we have to multiply that by 3, because we could have had our fish that has been shown as being non-diseased either first, second or third, and that would give an overall probability of 0.169. Part C. What is the probability that a fish is diseased given that the test concludes that it is? So if the test has concluded that it is diseased, it is this one and this one. So given that it is shown that it's diseased would be 0.47 on the bottom. But we want the probability that it is diseased, so that would be the 0.45. What we want divided by what it's out of, and that gives an overall probability of, and you could either leave it as 45 over 47, or you could give it as a decimal, 0.957.